Okay, so we're going to look at the volume of a triangular prism. And you guys should have your pink, hopefully some of you still have your pink formula sheet. I'm trying to remember what it tells you on that pink formula sheet.
It's like the capital B times something like L.
It's the capital B times the height? Okay. Well, when it's a capital B, that's the area of the base. And in this case, the base is a triangle. Okay. So let's actually do an example of this. My boxes are kind of small, so I'm going to just use my graph paper here and draw something out. Now remember, your quiz tomorrow is open note. So anything that you write down on paper and stick in your binder, you can use tomorrow. Hint, hint. Okay, so let's take a look at this triangular prism. Okay. Okay, so on your formula sheet, you're going to see that its volume is equal to capital B times the height. But really what this is it's the area of the triangle times the height or length of the prism, depending on whether it's on its side or not. Because if you turn it and have it like that, then it's the height of the prism. But when you have it laying on its side like that, it's the length of the prism. Okay? So let's go ahead and put some dimensions on here. So we'll say that this is 5 feet. This is 8 feet. And then the length of my prism here is 12 feet. Okay? So when you're finding the volume, you just find the area of your triangle and then multiply it times the length of the prism. Most common error is that people forget to divide by 2 when they're finding the area of the triangle. They just do base times height, and it's going to mess you up. Okay? So I'm going to do 5 times 8 divided by 2. Now this is the area of my triangle. So that's like the capital B there. Times the length of my prism. So the volume is 240 feet cubed. So feel free to add that to your notes, your study guide notes. What else can I help you with? What else do you want me to go over? Yeah, Pranish. Awesome. Okay. So let me scoot this up. Let's do, and Gabby, what were you wondering about? I want to make sure I have enough time.
Alternate interior angles.
Sweet. Okay. Yeah, I'll do that next. So I'll do his 2 problems and then I'll do some alternate interior angles. Okay. So here's a complex area problem that you might see something like this. Okay. This is a complex area problem. Okay, so we want to find the area of this figure. This is a great example of a complex area problem. So let's break it into pieces here. Well, first of all, we can see if I just chop it up a little bit, I have a rectangle in the middle and a half a circle here and a half a circle there. So altogether, we basically have a whole circle, okay? Now for this rectangle, the radius here is 4, which means that the whole length across is going to be 8 yards, okay? So that means my triangle is 5 by 8, so what's the area of my rectangle? Sorry, I said triangle. 40, okay? So this is 40 yards squared. There's that, okay? Now I want to find the area of this circle. Now, if this stopped right here, then you would want to find the area of the circle and then divide it by 2. But since you have the whole circle in this problem, you can just find the area of one circle. And that circle has a radius of 4. So this is going to be pi times 4 squared. Now, be careful when you are typing this into a calculator. A common error is that people will do pi times 4, and then they'll square the whole thing. That's going to mess you up. You have to use order of operations, so make sure you square the 4 first, and then multiply by pi. So I'm going to do 4 times 4. So there we have it. It's 16. Then I will multiply by pi, and I use 3.14 because I have a 4-function calculator that doesn't have a pi button. Okay? So that means the area of my circles, my partial circles there, is going to be 50 and 2400 yards. Yeah. So this is the whole circle, so it's both halves together. But like I said, if you only had 1/2, then you would divide that by 2. Now I can add these two up to find the total area. So total area is approximately, because we have a circle, 90 and 2400 yards squared. Okay. Okay, let's go ahead and do a complex area real quick, and then we'll go on to, that's what you wanted, right, Pranish? Complex volume, okay. Oh, that's what we just did. We just did complex area. All right, let's do a birdhouse. I like birdhouses. Or actually, maybe just a house. I didn't leave myself very much room. It's okay. Wow, they are loud today. Although I'm sure they say that about us all the time. I don't know, you guys aren't very loud. My 5th period, man, they are loud. Okay, so I'm going to go ahead and put some measurements on this little house here. So we'll say this is 10 feet, 12 feet. This is 16 feet. The height here is, let's say, 3 feet. And I think that's all we need. Okay, so when you look at this, I want you to think two separate shapes here. You have a rectangular prism on the bottom. You have a triangular prism on the top. Okay, so find the volume of both of them, and then you're gonna add them together, okay? So I'm gonna chop it up a little bit with my other color here. So let's do this one first, okay? The volume of a rectangular prism is length times width times height here. So that's pretty straightforward. It's just gonna be 10 times 12 times 16, and I get 1,920 feet cubed, okay? Now we wanna do the triangular prism. Remember with triangular prisms, it's very similar to the rectangular ones, but you have to divide that area of the triangle by 2, okay? Thanks, Bernice. So this is the base of the triangle is 12. The height of the triangle. Yep, up here. Thank you. Okay, so the height of the triangle is 3, the base of the triangle is 12, and the length of that triangular prism is 16. So I'm first gonna find the area of my triangle, which is 3 times 12 divided by 2. Now I know that the area of this triangle is 18. Then I'm gonna multiply by the length of my prism, which is 16, because we can see that down here. This is also 16 here. So times 16. And I get that this area is 288 feet cubed. Then I'm just gonna add those two areas up. And I get that the total, or sorry, the two volumes up. I get that the total volume is 2,208 feet cubed. Okay, so that's a great complex volume one. Okay, I'm gonna do Gabby's question real quick, and then Elizabeth, I'll go to you, okay? All right. I'm gonna get a new sheet of paper here. I'm just gonna put some parallel lines and a transversal on here so we can talk about all the different angle names. Can't see it. Well, that's kind of parallel line. It's a little wonky. That's okay. Or as my family would say, cattywampus. It's like our family word. I don't know how that started. Okay. Now remember, interior angles are the ones that are inside the parallel lines. And alternate would be on the opposite sides of the transversal. Okay? So since they're interior, we know that it's going to be one of these four. It's going to involve these 4 angles. And alternate means that one will be on this side of the transversal and one will be on this side of the transversal. So we can consider these a set of alternate interior angles, okay? And the cool thing about these is they're actually congruent. So if this is, let's say 39 degrees, then this is also gonna be 39 degrees, okay? And there's also a second set of alternate interior angles too. Here and here, these are considered alternate interior because they're on the interior of your parallel lines and they're on the opposite sides of your transversal. And if we know that this is 39, these are actually supplementary angles. So this will be 141 degrees, 141 degrees. Okay, because you can actually see it. See how it adds to 180 here, 180 here? Does that help?
Kind of. How do you know that it's supplementary?
How did I know that it was supplementary? Well, whenever you have this situation going on where you have parallel lines and a transversal, you only have 2 angle measures. They will all be one or the other. Okay, so like here, this is going to be 39 degrees because it's vertical. This is going to be 39 degrees because it's vertical. This will be 141 because it's vertical. This will be 141 because it's vertical. And I know that they're supplementary because let's say that this was 39. Well, then this whole thing is supplementary, so I could have found that. And these are corresponding, so if you slide those down the transversal, that will be congruent. These are vertical, so they're all kind of like interconnected, okay? So alternate interior angles are always congruent. Same side interior angles, like these ones, are on the same side of the transversal. They are supplementary. And if you go through the process of like, you know, moving everything around and filling in all the angles, you'd be able to see that they were supplementary to each other. All right, Elizabeth. What was your question, kiddo? Did you forget it? Okay, if you think of it, let me know. Okay, is there anything else you guys would like to go over? Yeah, Pranav.
Can you do similar triangles?
Absolutely. I love me some similar triangles. Okay. Okay. Let's go ahead and name this. And I like to just, okay, let's go through this. We're gonna run out of time. But basically, these are right angles. So we can say that angle B is congruent to angle E because they're right angles. Okay, and we can say that this angle right here is vertical to this angle. So angle ACB is congruent to angle DCE because they're vertical. And then we can write a similarity statement. So guys, I'll be in here during nutrition break and after school. So if you need anything, come on in, okay? Yeah,
So the next test doesn't have systems of equations, so how do I get that later?
we're gonna work on it next week.
And then if I do better, then
Yes.
I could go to.
Were you able to correct those answers?
Yeah, and I checked with Alan because I knew Alan had the right answers. And I
Mhm.
got the right.
Does it make sense?
Yeah.
Okay.
I just think it was simple stuff. I didn't put it in like X and Y with the parentheses.
Oh, yeah.
I also didn't do the math.
Okay. So yeah, we'll work on it next week. We'll make sure you're good to go. Okay.
Would it be a second test?
Gavin got quarantined along with a lot of other students that I have. Such a bummer. He won't be able to come back for the rest of the year.
So a triangle needs like at least two similarities to be a double.
Yeah. Mhm.
And you can put more, right?
Yeah, you can, but there's no way to prove that angle A and angle D are congruent.